Okay, greetings. I am Dan Hillenbrand, and I'm leading the Denver Open Source User Group tonight. And we have another Daniel who's going to be presenting tonight. So happy that you could join us. This is my first time actually driving the controls of the video, so wish me luck and make some comments if there's something going really weird. Appreciate that. So first, I want to talk about our sponsors. Okta Developer, which on their website, they are everything you need to know, everything you need to build or integrate authentication and user management. So Matt Rabel has been very helpful with the video via Okta Developer for our presentations, and he's now sponsoring the StreamYard, which we use for the presentation, which goes eventually to YouTube. PeerSource, a recruiting firm that serves all 50 states. Last time I talked to them, they were looking for remote Angular, Node.js developers, mobile app developers, product owner. So they normally sponsor our drinks for our in-person meetings. Skill Distillery, where we have met many times in recent months, well, maybe not so recent, when we were meeting in person. They are an immersive full-stack Java coding school. So I thank Skill Distillery for sponsoring us there too. Okay, No Fluff, Just Stuff series, world-class training for software developers and architect. By the way, this, that was for last month. I was gonna mention that, every Friday at about 11 o'clock Mountain Time, they have a nice free 1-hour webinar. So go check them out at nofluffjuststuff.com. Agile Learner, this is Venkat Subramaniam's deal. Instructor-led online live courses and many training videos on many topics that he is very knowledgeable about and loves to share his knowledge. So let's see, Agile Learner, we do have a year subscription that we'll be giving away later tonight. And also, let's see, JetBrains will have a free subscription for IntelliJ or one of their other amazing products. We have two potential new sponsors, Dimitri from Denver. They have custom software solutions, and they also have some software engineering openings. So check them out. That's Dimitri, Devetry. AMP Robotics in Broomfield utilizes robotics for recycling. Very cool place. Very up-to-date, state-of-the-art stuff going on up there. And they have both software and hardware engineer openings. So, hi Jim Moore, good to see you. Okay, Daniel Hinojosa. First, some of the things that he's done, he's done a lot of work on O'Reilly Learning. He's written some of the scenarios, the Katacoda, like spend 5 minutes to do something and learn something. I've actually been watching his beginning Scala video, which is about 9 hours. I highly recommend that. He has such a great voice and a great, I say, avuncular style, like a nice uncle that you might have. He doesn't skip over some of this stuff that a lot of people tend to gloss over, so very highly recommend that. But also coming up this Friday on No Fluff, Just Stuff, you have an opportunity to, he's going to be there, for 8 or 9 hours doing a deep dive on what's new in Java. So check that out on No Fluff, Just Stuff. Okay, now I need to start driving this. Whoops, I almost removed him. You ready to go up, Dano? Okay.
Let me get on the unmute here.
Okay, I can hear you now.
Yep.
All right, so we're going to talk about Scala tonight. So I guess I will let you take it away.
All right.
I'll rejoin you at the end.
All right. How many people am I talking to, just out of curiosity?
I will look that up. There's an actual show right here.
All right. That's fine. All right. So welcome, everybody. Thanks, Daniel. And this is the only place where the host has the same initials as I do. So I was enjoy coming here. All right. So what's that?
I just laughing. I better mute myself.
Okay, there we go. All right. So welcome everybody. So Scala 3 is going to come out sometime this year, or at least that's how I feel. It could just be 2022, who knows? But they try to get it right. Undertaking a new programming language tends to be kind of a tough thing. So I'm going to talk about some of the new things, but for this particular class, I'm going to be talking particularly about type classes. So a difficult topic, and I'm going to do it in kind of like maybe a short story, I guess, and come up with an ending. We'll see how this goes. I was planning this for maybe the last year. I didn't know how to go about it, but you're my first. No, not victims. What was I trying to say? Audience. And we'll see how this goes. All right. So anyway, Scala 3 is bringing up a lot of great changes. I think Scala is a great language. It's definitely one of my favorite languages, along with Java, and absolutely love it. I love the static type system. I love matching things up correctly. I like knowing that a program is going to break long before I compile it. I like that sort of feeling rather than just running it and send it over to production and then say, "Oh golly gee, what happened?" So I like that. I like knowing that up at the beginning. All right, so I want to tell you a little bit about Scala 3, but I'm going to do it just in kind of a little short story, I guess, and hope you enjoy it here. So I'm going to use, and I'm going to do a share screen over here. And if you have questions, please ask away. All right, so I'm going to share my screen. Here it is. All right, and Daniel, are you able to see this screen? It should say no main class detected. You see that okay?
I'm dialing it up now.
All right.
Okay.
Just want to make sure you got it.
All right, I see it.
All right, excellent. So SCSI is actually pretty amazing. It's SCSI, S-C-A-S-T-I-E. You can probably see it here on my screen, .scala-lang.org. It's an editor. Yeah, please go ahead.
It's hard to read right now. Can you
increase the font?
Increase the font.
Yeah, let's see what I could do. I don't have the biggest screen in the world, but hopefully this is a pretty big size.
Okay. Now that I've got my own screen big enough, I can see that fine.
All right. Yeah, and I know you wanted to see this on a different screen. All right. So I'm going to go over here to build settings. If you've never seen SCSI before, it's a wonderful editor. I could do Scala, and I have different types of Scala. I selected here Scala 3, because that's what this presentation's about. Scala 3 is not out yet, but we are on milestone level and soon to be released. So I just selected Scala 3, release candidate 3. So we're getting very, very close. And so I want to talk to you a little bit about Scala 3 and there are a lot of new features coming out, but I'm just going to show you a little bit of them. One of them is we have this annotation called main. And one of the things that I could do is I could just say def, and I'm going to say hello, Dosug. Say hello, Dosug. Here we go. Here, let's do OS user group here. There it is. And this will return a unit, and I will say something like, hello there. It's very good since it's the May the 4th be with you. So in the style of Obi-Wan Kenobi, hello there. All right, there it is. That's my little intro. So I'm just going to run my main method here, and here it is. I don't need any more, like if you're familiar with Scala, I don't need any kind of object or anything else like that. And there it is. And it says hello there. And everything looks great. So I don't need an object that surrounds it. No static. We never had static in Scala anyway. And that's our main method. Okay, so pretty happy. And I think it's pretty cool that I have such a lightweight main method. Some cool things about main methods as well is that if I ever have something like, some arguments like this over here, that it automatically does arguments for me. I could run it in the command line. It does all the type checking for me, and I could just run an application straight away. There's so many really cool features that I think you would just love as a developer. Okay, so I'll go ahead and save this. One of the other things I like about SCSI as a learning tool is that this has a URL. Well, everything has a URL, but this URL has an identifier associated with it that if I'm chatting with somebody, I could say, hey, take a look at this code. Tell me what you think about it. Okay, so I think it's pretty nifty. Scala generally runs like for large projects. The two favorite IDEs are IntelliJ and Visual Studio Code. All right, well, I'm going to get started here. If you have questions, I think there's a facility in order to do that. So I think just put it up in the chat, and I think Daniel will forward that over to me. So I'm going to do a method in here. Methods start with def. That's the way it always has been. That's nothing new with Scala 3. And I'm going to say find the max and with a default of 0. Okay, just a simple method. And what I'm going to do is I'm going to bring in a list of integer, and this is going to return a integer. So this method is going to take that list, and I'm going to take that list, and for every element in that list, I'm going to add 10, and I'm going to find the maximum value and return 0. Okay, seems pretty easy. And so what I'm going to do is I'm going to do this XS map. So we can do a map right away. So for those that are familiar with Java, I think you know what a map is. I think most of you probably know what a map is. Apply, a single function to every element. So what I want to do is I want to add 10 to every element. And I said over here that I want to find the max. So we have this one here like max option that we could do here. Let me come in over here and let me increase the font here. In case you're not familiar with option, we've had option since Scala 2. I'm going to run this here on Scala 3, so that way we can just take a look to see what it does. Option, so an option, here, let's do O1 here. We have something called sum, which says I have an answer, and the answer is 34. That's called an option. So there it is, sum of option. The other way that we do this is we usually do option of 34. That's a better way to go about it, because at least this one's the super type. The way options work in Scala, if you're not familiar with Scala, is that option is a super type, and it has 2 children. Those children are sum and none. That's the way that works. So we see here that the type, the inferred type, is going to be option, and we have sum over on the right-hand side. So I could create another one. Here's another option. So I could either do none, but I would have to create the type over on the left-hand side. So as an option int, here's a none. But another way to write that is O2 option empty, and I bring in the generic type. There it is, option empty with the square brackets, and I put the int in there. So that's what an option is. It's very much like optional in Java. Okay. So excellent. So what I want to do is I want to use this max option. And the way the max option works is that if I have a list 1, 2, 3, 4, 5 and do a max option of it, then what this does is it returns either a sum or none and gives you whatever the highest number is. Okay, and there it is. That's what a max option is. And then what I want to do is I want to do a get or else 0. Okay, so pretty easy in the way that works. And what I want to do is I'm going to do this print line, get rid of the hello there, and I'm going to call add 10 and find max default 0, and I'm going to give it a list. So list 1, 2, 3, 4, 5, that's the argument, and I'll feed that in there. I know it just seems like an oversimplified method. I have a point to this. Maybe I do. And here we go. So I'm going to go ahead and save that. And when I do this, then what I should see from this is 15. Right, because I added 10 to everything, so 15 is going to be the biggest number, and then I'm going to get an or else. Okay. So the method itself isn't the point. I just chose something simple so that way we can build off of it. Okay. All right. So that's the evaluation, and there isn't anything peculiarly Scala 3 about this. This is just a Scala 2 method. The main method is a little bit different. We've always had unit. If you're curious what unit is, that's analogous to void in Scala. And yeah, there it is. Now, I want to throw a challenge at this. So now, just like every basic story, you always start off at a green meadow before things get interesting. And here it is. So how about I do the following? How about I take this then, and I want to call it with 1.0, 2.0, 3.0, 4.0, and 5.0. Let me space it out a bit. Let me go ahead and save this. And let's see what happens. So can this work with double? I don't know. Answer is no. So this time I'm trying to feed this into the list, and it doesn't work. Okay, but I would love for to make this work, but it doesn't. Okay, so one thing I'd like to do is I would like to make this work. So what's the option that I could do? Well, if I was in a Java frame of mind, I guess I could do this, right? I could just create another method. As long as the arguments are different and the return type is different, then that should work. And I should be able to do things like this, like add a 10.0 or else do a 0.0. And now I have this double. And the signatures would resolve and I'd be able to run it. Okay? So fair enough, I'm able to do something like that. But is there another way? And the answer is yes, if you're using Scala. Oh, all right. So what do I want to do? I like Scala because I don't have to create a lot of methods. And now there's going to be a balance as to how you wish to particularly run this. So I have a list of double, list of int. Oh, let me do another one in here. How about I do another print line? And this time what I want to do is I want to do this one again. And we have something called Bigint. So how about I do Bigint 1, Bigint, here I'll do 20, I'll do Bigint 5, I'll do a Bigint, and let's do different kinds of numbers in here. Bigint 10, and then a Bigint, I'll do a Bigint 3. Here we go, Bigint 3. There we are. That looks good, and I'm going to go ahead and save that. Oh, here we go again. All right, so neither list of int. Do you like my acting? I'm trying to go for an Academy Award here. List of int, list of double does not work with Bigint. So Bigint is a type that we have within Scala. That represents a big integer. So here I go again, another copy for another type that I wish to use. So here we go, Bigint. There it is. Here's this Bigint. Okay. And if it's an I wish to add a big int of 10, max option, or else give me a big int of 0. All right, there it is. Let me go ahead and save that. And there we go. Yay, it works. But man, that's a lot of code. Ow, my fingers, they hurt so much. All right, so there it is. Can I do something about this? Well, let me make another attempt at this. And what I want to do is I want to create one method that rules them all without having to create duplicates like this. So here we go again. Def add. And this time what I want to do is do an add 10 and find max with a default. And this time I want to create a list of A. I just don't know what A is. This is a generic term, so I'm going to put a generic declaration in front and say, you're going to be expecting some type that is unknown right now, but as soon as someone gives me a list, we'll be able to resolve what this A is. Okay? Now, what we're going to be doing is we're going to be using one of the first type classes, and that's called Numeric. Okay? And a type class, well, here, let me show you kind of really quickly here what a type class is. So let me go here to source, Scala, and let's see if we have a simple type class. Yeah, it's just using show here. Here's a type class. This is like toString. It's called show. This trait that you see here is show. Let me close that out there. And this one just has a simple signature that whatever the implementation is, if you give me an A, I'm going to return a string. That's it. That's a behavior. And so what I could do for something like this is that I can create a show for strings, which is just going to print out the string. But if I have a custom class like employee, I get to, have different implementations on how I wish to do a string. This is what a type class is. And one of the powerful things about it is that if you ever use Java, well, I'm sure a lot of you have, or even Python or Ruby, that you have a toString implementation. And sometimes you wish you could change it, right? But if you change it, there's a good chance that you're going to break a lot of other things along with it. Well, this type class, I get to choose, which implementation do I wish to use. Okay. So here, I'm not a big user of Visual Studio Code, so I don't know what maximize screen is. Format document editor group, is it this one? Maybe. No, it isn't. I forgot what it is. Anyway, how about I do this? How about I do it the old-fashioned way? Like move that out. There we go. I knew I could do it. All right, so there it is. So this is a trait show, and I could make this implementation and have a default implementation wherever I need it. And this one's using something called a given. So if I want to, I can have one implementation that shows the employee first name first, and I could have another show where it's the last name first. And I have different implementations of a two-string. Wouldn't that be cool if you could have that? And here's the other implementation. And so what I could do with something like this is if in this scope I wish to implement, first name first, then I could just import this style. But if I want to change the style, I can just could just import the other one, which is employee show last name first. And so when I run this, and here, let me go ahead and run this. I think this is runnable in here. That when I run this, this shows James Gosling. But if I wanted to replace this and say I want to use employee last name first, and then run it, then just by the flick of a replacement of an import, and let me go ahead and run that. Maybe. Oh, it's compiling. But as soon as it finishes compiling, there it goes. Debugging console. Maybe. There it is. And there's Gosling James. Okay. So I could switch behaviors just by using an import. And that's one of the powerful things that we can have with a type class. Okay. So let me come back over here. So one type class that I can use is numeric. And we have this new term in Scala 3 called using. So let me use this numeric, there it is, of A. Because that's a generic type in here. So if I give it a list of A, what this is going to do is it's going to bring down the numeric type class for that particular type. Okay? And here it is. So what could I do with something like this? Well, I could rewrite this to say XS map, and then for every element, what I wish to do is I can call numeric. And numeric has a lot of really nice methods on there. And what's great about this type class is that I can choose any one of those methods, and it would apply to any kind of method. So here's numeric. Let's take a look at the trait that I can use for it. And here it is. Here's numeric. So I may use from int that allow me to convert a int to whatever type this is I'm using. I have minus, I have plus, I have 2 double, 2 float, 2 int, and a lot of other great things. So let me come in over here. And so what I want to do is I want to say numeric plus, because that's what I was doing over here. This is plus, but I'd have to use the actual plus method. And what I want to do is I want to add the I that is coming in, and I want to add 10. So I'm going to use this numeric in here, and I'm going to say from int 10. And there it is. Okay. So there's the map. And then what I'll do is I'll call max option, and then get or else, which allows me to get the value. But if that value is not there, I'm going to call numeric. And numeric has another wonderful utility. Let's take a look over here. And it's called something. There it is, 0. Yay. All right. So I'm going to call 0. So get me the appropriate 0 for this A generic type. And hopefully I'm not going too overly complicated here. And so what I'd like to do then is I'd like to see if this is going to work. What I'm going to do is I'm going to comment these out, and I have this one method now, and hopefully one method to rule them all. Let's see if I did it right. I may have not. We'll see. If I get a mistake, I'll fix it. Holy moly, that worked. Isn't that amazing? So what I could do with something like this is that. And now I have one method that will support integers as long as it is numeric. Let me space it out a bit to make it look nice. If it's a double or if it's a big int, all of these are numbers. And I have one method. I don't have to create separate methods for it. And that's one of the great things that a type class will do. Okay. Any questions on that? Or Dan, Daniel, were there any questions? that you know of?
I'm not seeing any coming in just yet.
All right, sounds good. Before it gets harder, just want to make sure.
Okay.
So what's this using here? Using is I wish to use a definition that we used to call implicit. I think we'll still probably call it implicit when it comes to Scala 3. This just means that within this scope, there's a definition for this, that there's a numeric somewhere. So let me come in over here and let's try an n in here, and I'm gonna say we have a new term now. It makes me feel like I'm practicing some witchcraft or something like that. So it's called summon, and I wish to summon the numeric for a long type. And there it is. And so this is why I'm able to do a plus of any kind of value like 2L and 4L from this, and I'm able to do any kind of mathematics on there. And it doesn't matter what kind of type it is. There are type classes for numeric long, numeric bigint, and all these different kinds of numbers. And again, the benefit for this is that I'm able to have one method. All right. Well, that one ended up working pretty well. So now what I want to do is I have all these lists, but what if it's not a list? Uh-oh. So here we go. What if I want to do, and so here we go again. I want to use this one method in here, and I want to use this with an option. I just told you what an option is. So here's this option, and let's say I want an option 4. And what this will do is, given this option, I want to do the same thing. Okay, this will take the information inside of it, add 10 to it, and find the max. Well, this is the only max here. This will be a 4 will be the max. I'll add 10 to it. And what I should get out of it is an option or a sum value of 14. Okay, it seems pretty easy that's the way it should work. And boom. So this one says, I found option int, but I required a list of something. And so that doesn't work. Okay. So what am I going to have to do? Well, let me clear messages here. Well, it seems like I'm back to that square one. At least this time, I get to have like different collection types. So A still stays the same, but here's option. So here's option A. Here's numeric. And what could I do with this? Well, I'll keep it as excess to keep it simple. Option has a map. So what I could do is take that number and add 10, and here's the get or else. It seems just like a lot of work just to change the option in here. Let me go ahead and save that. And let's see here. Something, I think right over here. I need one more paren. There it is. And so I'll go ahead and run this, and everything works. But now I got like 2 methods now. Okay, so that's a little bit of a bummer there. Okay, so what could I do with something like this? Well, one of the things that I can do, again, my goal then still is to have like, one method to rule them all. And let's see what I could do. So let me make a copy of this and see what I can do with something like this. And one of the things that I could do is I could say f of this. And you're like, whoa, what are you doing there? What are you doing there, little buddy? F bracket underscore. What is this? In Scala parlance, this is called a higher kind of type. And the F could represent anything as long as it has this shape. And so what is this shape? So F of underscore could be a list of int that has that shape. Could be set, probably not a good one. I guess it could be set, but it's not lawful. So we usually don't use set for that sort of thing. But option of string, that has that same kind of fit to it. A try of a float. And you see here, we're looking for a shape, right? An that contains us. It's kind of like what this one's saying in caveman speak. A list of int, a option of string, a try of float. Okay. A future of, I don't know, employee. Okay. All these types have a certain shape that's associated with it. And this generic is saying, look, I'll accept anything of this shape. Something of a something. And it could be either one of these types of collections. So I want to make this generic. So I'll change this one to f of a because I don't know what it is. I'll need to make sure that a is numeric, f, and it has the shape of f of a. So that way I could do a map, do the numeric plus the max, and here's the numeric on here. Let's see what this will get us. All right, and here it is. F of a is just raw. It's just the thing that we have. Something of a something, but we don't know what it is. And it says right over here that I don't think it has a map. I don't see a map for this. So what now? Well, let me do the following. So let me clear the messages. It doesn't have a map. So what I'd like to do is I'd like to create a type class for this. So what I'd like to do is I'd like to do a trait that's called a functor. And you may have heard some of these funny terms when functional programmers do it, but what a functor does is map. And sometimes I think functional programmers sometimes make definitions that make things a little bit hard to understand. Functor is map. What's the other one? Monad. Yeah, I was like, what's the other one? Monad. You probably heard of monad. And it's like, oh my gosh, that sounds scary. But what monad is flat map. That's it. It's just a method that has flat map. Now, there's a little bit more to it. There are laws that abide to it. But really, it's just a thing of a certain shape like this that has a flat map, and he could do a flat map on it. That's all it is. Okay? All right. With some features, of course. Anyway, so here's a trait. So what I'm going to do is I'm going to define a trait, and I'm going to put a colon at the end of this. And a trait is like an interface in Java to where it's purely abstract. And what I'm going to do is I'm going to define a method in here called flat, or not fmap, just fmap, not flat map, just a regular map. And so here it is, fmap. And fmap is a method that, let's say I'm going to have an A and a B associated with it, that this will say, if you give me this thing of an F and A, again, F could be anything, list, future, try, whatever. As long as it has a shape, go ahead and bring this in, and go ahead and give me a function from A to B. And I will give you in return a thing or a container of B. Okay? Whatever that is. And there it is. Let me go ahead and save this to make sure that everything is good. Okay, so this is still, not right, but that's okay. And so what I'd like to do is, since this defines a map, what I'd like to do is I'm going to do a comma in here. And inside of this using, I am going to bring in a functor. So let's see, where is it? I'll call it the full name here, functor, and functor of type A. Let me know if I'm losing anyone. We're going to go into the depths here now. Just like any story, right? I said I was going to tell you a story. So now it gets exciting. Okay, the tension builds. All right. Okay, so here it is. F of something, a container of something. And it doesn't matter what it is, because sometimes I want to run this with an option. Sometimes I want to run this with a list. I want to run it differently, however I want to. So here's f of a. Here's numeric. Here's functor. I want a, oh no, this is wrong. This is not a. This has to be a functor of f. And why this? Because this f right over here is the thing that needs to have support for a map. So I got this part wrong. Good thing I caught it. And there it is. There's that functor. And now that I have this functor, I could rewrite this a little bit differently. But what I'm going to do is I'm going to comment this part out, because I probably want to try to find a way to write this the way this is without changing it. But that's not my goal right now. My goal is just to try to make this work. So functor fmap, that if I'm given this f of a, is this right over here. If I'm given this f of a, in fact, yeah, I'll just leave the name as is. Again, variable names don't matter. So I'll do x of s here. And the fmap here has a function from A to B. From A to B. So what is this function? This function is this one over here. So let's say I want to copy this particular function. 1 parenthesis, 2 parenthesis, and done. Okay? And there it is. So this functor is going to return maybe a list of something. Let's see what happens if I just copy this and bring it over and see if that works, this max option in here. Okay, so let's see what we have here. I have Functor with an Fmap. The X of S is coming in. I have this one right over here with this max option here. Let's see. And I have this 10. Oh, and then the end here, I think I got rid of whatever I'm trying to return here. And this one is supposed to return a option of A. So because that's what I needed. Let's see, max option is not a member of F of B. Here, let's do this. So this one is F of A. Great. I have this Fmap, which I'm bringing the F of A. I have this function that given this I have this numeric plus, and then this numeric int. This is returning a F of A, which is what I want to. But I think one of the things that I'm going to need here is something else. And that would be max option on here. Just because this one doesn't match the types quite that accurately on here. So it looks like I'm going to need a little bit more work on this. So right now, it kind of works okay on this. I have the numeric plus. The functor works. This one's returning a F of B. So if this is a list, this will just return that F of A. But what I want out of this is this max option. So almost there. So what I'm going to do is I'm going to do another trait. And I'm going to use another one called Foldable. There it is. And this one is the one that's going to be able to have max option. Okay. So max option of this, let's use an A in here. And I'll call another FA on this. And this will accept a F of A. And max option will take this, and this will return a option of A. Okay. So that's the first one that we're going to add here for max option. And the reason for this is because there's another type class called Foldable that has this particular max option that returns a option. Now, one of the things that I'm going to include here is another kind of implicit binding that's called ordering. Ordering of type A. Okay. So that's the signature. And so here's the folding. Let's see if this is going to work. So I'm going to add a foldable to this, and I'm going to say I'm going to require a foldable for this of type F. So I have functor. Let me just double check. I have functor. I have, let me make sure I got the signatures right. I got functor. I got foldable. Everything looks good. And I have some foldables associated with it. So I think I'm good. Max option. Yeah, and I think all this looks good. Here, let's save it. And let's see what we get out of this. So this one required F of A, but this time what I want to do is I want to call foldable, and I want to call max option of this. And here it is. And let's see what we get out of it. There it is. Okay, so we're getting a little bit better here for these options in here. So I'm able to call, or at least I'm able to compile this. These are not using this quite yet, but I'm going to get this to work. All right, so almost there. So I have numeric, I have functor, which is in charge of map. I have foldable, which is in charge of max option. It looks a little bit different than what this one is, but maybe we can recover. Okay, so if I remove these, which is my goal, and inevitably, I don't think this is going to run. Let me go ahead and run this. I think we're going to have problems. Yeah, here it is. And it's going to say in here, I don't have a functor list for this parameter. I don't have a functor option, so I don't know how to deal with any of this. So I can't turn these off quite yet. I'd like to, but they're not ready yet. So what I'd like to do is I'd like to create some definitions for these, for this functor and this foldable. So let's give this a try. So what I want to do is I'm going to say object. Object is the way that we create statics. So in here, I'm going to create some items in here. Let me use object lists, for example. And so one of the things that I would like to do is create a given. So given is a binding, kind of like what you saw over here when I was showing you this kind of type class here. So given is a binding, and here it is. So what I could do with something like this is I could say given functor for a list with, and now with this, I can create some kind of definition. So what is a functor for a list? Remember this F or this shape, that's the list that I'm going to define here. So if I have a list, let me go ahead and create this Fmap in here, A to B, which is what that is. And then this definition, this F of A, let me just call F of A. This time that's going to be a list of A. And then the function here is going to be from A to B. This will return list of B. So this is the concrete definition for what we see here inside of Functor. And the answer to this is going to be, since this is a list, I'm just going to use the regular map for this. Let me save this and let's see if things are okay. Everything is okay. So that's the functor for list. Let's see, I'm also using an option in here. So let me bring in an option as well. So I need a functor for an option. So what's the definition for that? Here's functor for option with def fmap, again, A to B. This time, F of A is going to be an option of A. And here's this function. Okay, and this will return a option of B. And for this one, I could create my own implementation of map. Like, I could create a for loop on here, iterate through each one, and apply the function for each one if I want to. But I'm just going to be lazy, and I'm just going to call map on that particular option. I'm going to go ahead and save this, and let's see if everything compiles. And it does. All right. So far, so good. Now, what I want to do, again, my goal here is to remove these methods and just have, again, one method to rule them all. Here we go, and I'm going to hit save. Let's see where we're at. Okay, so these functors are not available yet, so I'm going to make these available. So in other words, they're not bounded yet. They cannot be recognized. So what I'm going to do is I'm going to import lists. I'm going to bring in the given for it. Or it's called, I think I called it lists plural. Okay, so all those implicits should be available. And there it is. But we have another problem. There are no foldables either. So what we need to do is we need a foldable definition for all these. Okay, and then I'm going to do a pause, describe the reasons for this, but almost there. And what I'm going to do is I'm going to create some foldables in here. Oh, you know what? This is in the wrong place, isn't it? I didn't even see that before. So I'm going to bring this one over here. There it is. And there's my given. Oh, one of the things that we get with Scala 3, you probably had noticed, is I'm not using a lot of brackets. And it's amazing I'm kind of already used to it by now. So even this one over here, I think I could get rid of these brackets. This is getting very close to Python as far as the formatting goes. Here, let me save this. Sometimes I use the brackets. Sometimes I don't. See how it's not, going to even complain about it. So that's one of the new features that comes with Scala 3. All right, so here's functor for option. Let's see, what else do I need? I need a foldable for list and a foldable for option. So let me create those definitions. Okay, so here it is. Let me do it again, but this time not for functor, because functor provides a map. This time I need a foldable. So how do I fold a list? So here it is. I'm going to do a with here. And what I want to do is def fmap A to B. Let's see, it's not fmap, silly me. Foldable is max option. There it is. Max option A. Here's the signature here. Now I don't need F of A. I just need whatever this type is. F is now a list. So I'm just creating the definition for that list, okay, for max option. And this max option is going to return a option of A. And what I think I'll do is I'll bring this one over as well, okay? So there it is. So what's the definition of this? Well, since this is a list, I'm just going to do max option. Again, just be lazy. But if I want to create my own implementation of this, I can certainly do so. All right, almost there. Let's do a save here. I think it's good. Is it? Oh, almost. Woo! Look at this. Functor of option. I thought I did that. Oh, no, I didn't. Because here are options in here. So I need the functor of option. And let me go ahead and bring that in. Question? I hear a mic on.
Yeah, we've got one question.
Yeah, sure.
Your Python comment. For not using brackets, does Scala 3 require strict spacing a la Python?
Yes. I mean, everything has to match up. So here, let me try to mimic a situation where things don't line up. Now, this one I'm going to go ahead and save. Let's see if this works here. So here's the options I've given. So this one's going to say, let me just say this one over here. I need a foldable of option in order for this to work. So I'll work on that. But the other comment is, if this is a bit off, here, let's try to make this a little bit off here. I'm kind of surprised it didn't do it, but it is going to be, and maybe this one there's going to be lenient about, but it's going to be strict about where things are going to be located. If it can't determine what it is that it's looking at and it's unable to parse it in any way, then the compiler is going to say, hey, no, no, you can't do that. And you're just going to have to fix things and make sure that everything's lined right. All right. Yeah, another question?
Well, no, just a FYI, the time delay on this is somewhere between 30 and 40 seconds. So they haven't even heard your answer yet, but they'll get there.
All right, excellent. No problem. All right, so I have one more item, foldable. I don't have a foldable for option. Remember, foldable is the thing that is going to give me the ability to do a max option in here. So here it is, given foldable for option. So how do we fold an option? So I'll put a width in here. Def, here's max option. The signature for all this, here it is. Let me just bring that kind of in over here, except this is not a list. This will be an option that will bring in the ordering, and this will then return a option of A. For this, I'll just do max option on that. And there it is. Now, are we getting close? I think we're very, very, very close now. And so what I have here is I have the, oh, I already had commented out. And I think it works. So option 4 here, let me run this again. 15, 15, and 14. Yeah, here's the option in here. Oh, that looks fantastic. Here, let me clear the messages here. Let's bring this in. And there it is. Now I could remove these. Okay, and there it is. Now, it looks a little bit weird. I'll go ahead and admit that. For the unseasoned developer who needs to read this, that looks, there's going to be a little bit of a learning curve here. But let's take a little pause here. What is it that I'm doing? I'm bringing in, and here's how the powerfulness of it is. I'm bringing in a shape. Again, I could bring in a list of int. I could bring in option of string. Well, maybe not a string because it's not numeric. Because this is constrained, this A. This A here has to be a numeric. And so that's one of the things that this using will do, is that if there's no implementation or there's no given for this numeric, then this won't compile. And so it's almost like we're enforcing that A has to be a numeric. We are also enforcing that this functor that there's an implementation for this f. So in case I call this method using list of a, well, f becomes list, and what I need is a functor of type list. And here it is. Here's where it's given. And so in order for this to work, I need to import this in. So bring your questions on this one. I think there's some powerfulness to it, but also, I think there's going to be some fear with doing something like this because you fear, maybe perhaps that using terms in here is a little bit weird. But it's an enforcement, and also brings in behavior that's defined elsewhere. And here's the other thing about doing something like this, is that most of the time you just do what is below this line. There are libraries within Scala, and there will be libraries for Scala 3 that will have definition. Well, this one already has definition. The language provides it. But something like type level cats will have functors for lists, for ethers, for tries, and for very common values like option. They will have foldables already available for you to use. And so all you have to do is just say, I wish to bring this in. And it has to look this shape. And there has to be a definition where A is numeric. It has to be a number. And this has to have the F, or the container that this represents. That has to be a functor. In other words, it has to have map. And it has to be foldable as well. So that way I could use something like max option. And I just have one method. I don't have to have like different kinds of methods. And it works for all of these. Any questions? And so even, take a look at this. Just because I have this one method that is very flexible, let me hit enter here a couple of times. I'm going to add another print line. So now I have option. Let's use option with Bigint. Oh yeah, here we go. All right, question. Yeah, go ahead, please.
Not so much a question as a comment, which I pretty much agree with. It seems to make sense, but we'll need to play with it to get it to stick. Reminds me of being in college and didn't quite get that seminar.
Yeah, or whatever. No problem. Party all the time, really, right? Yeah, that's right. Yeah, go ahead, Daniel.
What's really cool is, this is being recorded. So when I learn a little bit more about functional programming, then I can come back to this and
absolutely
run it over again.
Yep, that's right. Okay, so we have this, and let me see what else I can do for this one. All right, here's another one, and we're going to add this other element, and then we'll go ahead and clean it all up and have our final presentation on this. Okay, here's another one. And you thought that was hard. Well, here's another one that you'll want to learn a little bit more of. So let's say I have print line, and I want to do add 10 and find max default of 0. And this time I want to call this with either. What the heck is either? Either is a type, so here's an either type. Someone had asked me yesterday in a different class for Java about, it was for my Scala class. I did one for O'Reilly. And someone asked me a great question, not a great class. Someone asked me a great question. How do you handle try catch? And I'm like, I don't think we do. I don't think we do that often, even though we have kind of like a try catch. We don't. We have, we could do a try catch. So we could do something like, 5 divided by 0, for example, and we will catch that. And let's see. I don't know why that one was here. Let me try to do maybe a print line here. Oh, maybe we don't even have that anymore. Or am I thinking we have it like this? I can't even remember how it works. But in case this E is a arithmetic exception, then what I will do is I'll print line div by 0. So we could do something like this. And I thought this is the way we did it. But I guess not. Oh, yeah, there it is. So, yeah, we could do a try catch. And that's the way that works. You could kind of tell I was kind of clumsy with that. because I rarely ever do that. We have something called, and here, let me show you in here, import Scala util try, which we can do for this, something like this. So let's do the same thing. We have this. Now, the way we do it in Scala is like this. We have a try, and we'll either get an object that represents failure, or we will have an object that represents success. Okay? Question, statement, go ahead.
Okay, another question here. You showed using summon briefly.
Oh, yes, summon.
Should that be handled by the compiler, or are there cases when you will use it directly?
So it's always the compiler. So summon and all this that I'm showing you here is all compiler based. So anything that has to, we used to call them implicits, but we're using, given, summon. All these are going to be compile time. And that's a great part because I get to know, anything that is going to fail or not succeed at compile time as much as I can. So all compile time. Okay. So like, let's say, given, let's see here, given, can we do a val still? How about this one here? Have a val int 40. I don't think we need this here. Yeah, there we go. So here's a given of int is equal to 40. And here's summon. So if I want to summon something of this particular type, then I could do so, and it brings in that particular type. But that's all the compile time. Everything is compile time. Everything's wired together. And here's the thing, because at runtime, it's just Java. Okay, so after you compile everything is just turns into Java code. You could introspect it with Java P or whatever it is that you like. All right. So we have this either, because someone had asked again, how do I handle errors? The other one is either. Let's take a look to see what either is. Here is either. Okay, either is a generic type that has a left and a right to it. Okay, so let's say the left will be a string. So if something goes wrong, that will be a string. Otherwise, it will be an int on the right-hand side. So if it's something that's good, right-hand side. So it's kind of like, remember, people used to be forced to either write right-handed because they were left-handed, and they were forced to do it because some thought left-handers were evil. And maybe they still are, man. I'm just kidding. They take the same semantics over here. So we have this either. So if it's good, it's right. If it's bad, then it's left. But it has to match these particular types here. Okay, bad. And so that's what an either is. Okay, and this is another way that we handle exceptions or errors. So let me come back to my my Scasti over here, and let's give this a try. So what I'd like to do here is I'd like to create a either. So I'm going to do val e either string or int, for example. Okay, and this one will be just right 30 for example. And now let's say here's that either, and let's say what I want to do. That's a number, right? But what I want to do is I want to use this e and send that through. Let's see what happens if we save it. Problem. No implicit argument, and what the heck is this? Was found for the parameter functor of this. Okay? This is what's called a type lambda. And it looks pretty funky, but it's not that bad. It's really a function on the type system that if given a b, I'll go ahead and fill this hole in with whatever it is. And that's what we're looking at here. And if you're like, what? What are you talking about? The reason is because everything in here, well, including this method in here, has a f of underscore. It has a certain shape that's associated with it. F, it has to be this type of shape, and it only has to have one thing. But either has two things, right? That's the wrong shape. So one of the things that I would need to do is create something that would take that away. So one of the things that we used to do in Java, or I'm sorry, in Scala 2, is create a type like myEither, where we would have a type like this, A, is equal to the type string in A. And this would be the whole, the A in here, meaning that you could replace this with whatever type you want. And if you take a look here, this myEither that you see here fills in that particular gap, or has that particular shape. Let me phrase it that way. Because remember, the shape I'm looking for is this, container of something. And now this is a container of something, but I had to do some fancy footwork here in order to do it, because this right here is a hull. So if I say myEither of int, well, that's the same thing as either. It's kind of an alias in either of string with an int. Okay? So that's how I could go about it. So one of the things that I could do is I could say myEither of int and set that through. Okay, let's give that a try. Let's see if this works. And kind of it does, but this one still says there's no implicit argument for something like this. So let's do the following. I'm going to move this up here, just that way we can fully reference that. And this one says, I don't have a functor for this. So let me create a functor for it. So I'm going to say object myEithers. Or I'll call it myEithers. And so I want to create a functor for it. So this will be given functor myEither and a, what is it, an int? Yeah, it looks like it. myEither, or you know what? Let's just call it myEither, because it doesn't matter here. Because we'll have this A in here. And this will be myEither. I will have a function along with that. And for this one, interesting on what I would do here. No, I think that would work. I think all this would work. Here, let's save it and let's see where we're at. Okay. So this one, oh, this one's not quite there yet. myEither. Oh, this one's not correct. This has to be myEither as well. All right, let's give it a try again. Let's see if it matches things up. So here it is. I'm bringing in this myEither, but this one says there's no implicit argument for the type either A, which I'm okay with. So this is the old way. myEither can be written now like this. That's the same thing. So this one says, if you give me an A, I'll fill in this hole here. And that's called myEither. And let me go ahead and save that. This one's still going to complain that this myEither doesn't quite fit right. But that's the signature. And then what I could do with something like this is inline it. And I'm going to try to inline it right now. So I'm going to take that. And what I'm going to do is I'm going to provide the definition. Oh, you know what? Let me take this back because there was something I forgot to do. And here it is. Let me do an import myEithers given, because I think that should have worked. Here, let me bring this back. There's myEither, myEithers given. There it is, and there's the functor for myEither. Okay, it still didn't work. That's fine. We can make this work. Okay, so here's myEither. Another way that I could write this is like this, as I stated, and this is called a type lambda, big name. This just means this is like a function that if you give me an A, I'm going to fill in this hole inside of either. Now this one still has an issue with this because the functor in here. Oh, you know what? It does work. Silly me. Here, let me give this one a try again. I wasn't looking correctly, was I? I wasn't. It did work because I forgot one other item, foldable. So let me do it here. It did work. Very good. Here it is. So foldable with myEither. Beautiful. There it is. And max option, except this one's going to be my either of A. I'll bring in the ordering, and we'll just do a max option on it. Would that look good? Yeah, max option. Oh, yeah, that's a good idea. How about we do that? 2 option. Thank you very much, Scala. You're very helpful, Evid language. All right. Hey, there it is. So that worked. All right. I love it. Okay. So I'm able to create a definition for this. And now what I could do is I have this type. And so this is a Scala 2 way to do it. All right. Let me take a breather here and explain. Again, things have to be a certain shape, like this F of underscore has to be this sort of shape. So I need to manipulate things within the type system in order to make this work. And that's a manipulation here. Now, I could rewrite this like the following. As I stated, this and this are the same thing. Scala 3 does a better job of doing this. And this is very much like a function. And you could see here, everything works. This is, if you give me an A, I will take that A and fill in this particular hole for it. And now what I want to do is I want to take this type. So whether I have this term my either on here, what I want to do is I want to inline it. This is actually a type that I can use. So I'm going to inline it. It's going to look a little bit funky, but I'm going to bring this in. This one just says that given this A, this will be replaced inside of the either. Okay? And there it is. And so for something like this, let me give this one a try. I think I could do either, and as long as it has a string, that would satisfy the type system. This may seem like, whoa, this is getting a little bit complicated. Maybe. I mean, I think there's going to be some, learning that has to be done with this. I'm not even sure I'll get this one right, but I'm going to try it anyway. Yeah, here it is. So this one is just given the A, I'm going to, return that type where that hole is filled. Here's the either for it. Here's the function. And for this one, let me just change this back to either string and B, if this works. And I think everything is lined up. All right, fingers crossed. I hope everything fits. Oh, yeah, I need to get rid of this. Let's hit save. Let's see, ambiguous part in here. Here, let me just remove this then. Or you know what? Let's make this one an either, a string, and a int, because that type's no longer available. And it works. Oh, yeah, there it is. Okay. So either can be now, put in here. And now I have that one method to rule them all. Now, last part in here is one of the things that we can do is we can do this a little bit differently, and that is using something called an extension. Let me tell you what an extension would do on here. So I'm going to come in over here. So one of the things that we could do is we could do an extension. Extensions are really cool, and here's a very simple example of an extension. Okay. So a number doesn't have is odd or is even, but I could make it. Okay. And so I could say extension of type int, I would like to make it is odd. Of type int, I'd like to make it is even. So if I call is even or is odd, that should work. So if I run this particular method, 10 is even should return. That looks weird. Did I get that right? Oh yeah. Oops. Bug. Someone fill in this. Someone fill in a pull request here. This is terrible. All right, here we go. One more time. I'm like, man, that logic's really wrong. All right, here we go. So 10 is even. Something was wrong with the universe there. So again, these methods don't exist. And so an extension provides methods to a type that doesn't exist. And you can add this whenever you need to. And so what I'm going to do, rather than do all this typing in here, what I want you to take a look at here before I replace all this, it's still the same thing, but I'm going to replace nearly all of this, but the functionality is going to be the same. But the thing I want you to take a look at here is the way this looks and the way this looks. Remember, the way I wanted this to look is like the way I had this originally. XS map, do a max option, get or else, numeric 0 on this. Okay? And again, I want to call it add 10 with a list of numbers, a list of doubles, a list of big integers. As long as they're numeric, all of that should work. Okay? And as long as that shape works, we're good to go. So what I'm going to do is I'm going to go over to my gist where I feel like a cooking show. I already had this prepared. So I'm going to take it out of the oven right now. Let's go ahead and see how delicious this is. All right. And here it is. Okay. It's the same one, except what I'm going to do is I'm going to copy most of this, and I'll go ahead and replace this within Scala. And we'll take a look at some of the differences in here. So what I'm going to do is I'm going to replace all of these, and they're going to take a slightly different look. They're going to be using what's called an extension, because the way I want to do it is like this. So here it is before. So what I had to do is I had to call Functor Fmap and then have this list in here. And then, so that's the list and that's the function. But I'd rather use it like this. This seems more natural to me. Take the list and call the map and then call max option on it and then call get or else. And so I'm going to use an extension with these traits in order to get this to work. So let me go ahead and open up the oven, and let's go and take it out. Let me get some oven mitts. Take out this hot fresh Typeclasses. Let's go and bring that in. All right, here we go. Let's see. I think what am I replacing again? Pardon me here. Here, let me do just this one. I just want to copy these ones. All right, I'm going to bring back over to Scala, and what I'd like to do is do this. They're the same definitions, but what's different about this is that I'm using extensions. So this means like if F is a list, then list should have something called my max option from this. Okay, which reminds me I need to rename this when I turn that one on. Here's Functor with Fmap. Here's list with my max option. And you'll see here that all these are extensions. And that what's able to afford me then is this. Here, let me do this, and I'll probably have to do some cleanup. I'm going to go ahead and comment this one out because I didn't like the way that one worked. And I'm going to try to bring this one back in, where I have a list, and I have a map, and I have max option. The only thing is that I need to change some names. Fmap, and I think I called this one my max option, I think. Yeah, my max option is what it's called. And here it is, my max option. And there we go. Is this going to work? Let's find out. Let's see. I didn't call it my, yeah, I just called it ethers, not my ethers. So I'll just bring in ethers. Let's save it. Let's see. A required option A. Oh, that's right. It should be A. It should not be option A. Because I have a default. The default should be 0. So thank you, type system. That is absolutely correct. Yeah, in fact, I was writing that wrong. I shouldn't have it returned a option. I should have just returned what this is. So here it is. Again, I'm using these extensions. I didn't want to type this whole thing, so I just had this already pre-prepared. So this allows me to call. So here's an example in here. One more example. Let's just make this a little bit shorter and sweeter. Print line list 5, 90, -1, 12, and 400, and 6. And I want to pretend, or not pretend, I actually want to do it, that I want to call my max option on this. Here it is. And if I save this, you'll see that this comes up with sum 400. Isn't that amazing? It looks like that there's an actual method in this called my max option that didn't exist before. But all because I wrote this using an extension, it looks nice and natural. Okay? Now, just focus on this code in here. Does it look hard? I would say the bottom part, no. As a user of this doesn't look hard at all. But the understanding of this is going to take you some time, but it's worth it. Because can you imagine how many methods I had to create for this? You already saw that I was building up to like 3 or 4 different methods for a different number, a different collection, and that would have been a lot. I have one method to rule them all. So let me clean this up. Here's the final product, XS Fmap, my max option, and I can plug this in with any kind of number that I want, be it a big int, be it a double, be it an integer, and this one function will accept it all. And it's very generic. It's using something called a higher kind of type. So if I want to give it a list, if I want to give it an option, if I want to give it an either, as long as there are definitions for it that have already been made, I can call this one method. Can you imagine how much code you can get rid of if you just had one method and didn't have multiple signatures for any kind of variation that we had? Now, again, if you're using, take a look at the project type level cats. You're using something like type level cats. They already define most of these things, like functor, foldable, for lists, for options, for either, for try, for all these basic combinations. And so really all you do is you just focus on this part, what you see here on the screen. All this extra plumbing is already done for you. You just need to make sure that you, bring in the correct imports, and then you're good to go. All right, I know we're on a 30-second lag. So I await your questions. What do you think? Scary? Awesome? What are your feelings?
For me, it's a matter of getting an idea of what's available out there. That's what I think a lot of these user group meetups are all about. You may not necessarily know how to do everything when you get out of it, but knowing what's available is the cool part for me.
Yeah. I agree. I think one of the things is that, with the future of Java and all the different things that we are seeing now, a lot of it has come, a lot of these ideas have come from Scala, but certainly some things have been a refinement. I think Java takes a look at what Scala does, and, to Java's credit, they'll say, you know what, that's a great idea, but we can do it one a little bit better. And there are a few cases, and I can't remember the specific cases right now, but there are a lot of times where that certainly is the situation.
Right now I'm doing some administrivia here.
Yeah, no problem.
We've got some door prices to deal with, so I'm just going to have folks email me at a email alias that I have.
All right.
Your choices are going to be the Agile Learner from Venkat and the JetBrains product.
All right.
So.
If there are no questions, I think I'll sign off because I have a little India gig that's coming up at 9:30, so I'm going to stretch and get something to eat before I have to go to work again. But if there are any questions, let me know.
Okay. Got a couple of comments from Jim and Martin. One of them is lots of laughs. Scala is like old Haskell saying, if it compiles, it's right. But getting it to compile?
I love it. That's fantastic.
And then Martin also has a comment. Absolutely, Jim. I'm going through functional programming in Scala again, and it talks about the signature leads you to the implementation because there's only one you can compile.
I love, I wish I was better with words like they said it. But yeah, you're right. If you kind of pit the types against itself, And there's really going to be very few ways that you could satisfy that particular type. It's really stringent. It really takes a lot of time. You can't fly. I don't know. I'm trying to do the analogy, fly by the wheel. I don't know. You can't fly by night, I guess, or you can't be too loose like you can with a dynamic programming language that allows you to do anything and everything. You have to think about how you're implementing things when it comes to a static type language. So I love the way that was worded. That's fantastic.
Great. And I've got some thanks from the folks watching. So thank you very much.
Yeah, appreciate it. Thank you very much, Daniel. Thanks, everyone. Dosug, and appreciate it. And I hope you have warm weather all throughout the summer and no surprise snow attacks.
You never know.
Yeah, you never know, right? There could be that May 15th blizzard. And if there's a blizzard, sorry, I didn't mean to jinx it for you.
1998, June 4th, we had 4 inches of snow on the grass.
Wow, that's nuts.
Remember that day. So how's the weather in Albuquerque?
Great. It's fantastic. I think it's like 82 right now. All right. Well, thank you, Daniel. Thanks, Dosug. Appreciate it.
Take it easy. Okay, so I just posted on the comments where you can send your preference for a door prize to. We've got the VenCats Agile Learner subscription or the JetBrains product, and I'll try to get that figured out tonight. What else? I do have some other things. Oh, upcoming, we've got Michael Carducci. He's not on the schedule yet, but he's committed to do something up pretty soon here. And VenCat himself will be here in a few months. And I think that's all we have. So thank you, everybody, for being here. And I'm guessing there'll be a lot more that show up afterwards watching this, which seems to be the pattern during COVID. We get a few people watching live and quite a few people watching it later. So cool. We'll see you next time.